Hey guys, today I'm going to show you what is meant by apoptosis volume decrease. To first be able to gain a better understanding of this phenomenon, I'm going to quickly go through intrinsic and extrinsic pathway. So intrinsic pathway, it looks a bit hairy, but just get a by here that upon getting a severe DNA damage, there will be proteins such as Bax being produced. So what does the Bax do? Bax would produce a hole inside the mitochondria, where the cytochrome C, which is a main electron carrier inside the mitochondria, can be released, and eventually would, upon release of this Bax protein, we're going to form apoptosome by binding with the APF1 and binding of the pro-caspase 9. So this means it was being inactivated. Caspase 9 was present on the cytosol of the cell, but it was inactivated. Upon release of the cytochrome C, it will be activated and it would form the apoptosome. Apoptosome would then give rise to caspase 9, activate the caspase 9, as you can see. Caspase 9 would then form a caspase 3 and eventually form as apoptotic cellular apoptosis, meaning the cellular death. Alright? Now, then I'm going to quickly talk about extrinsic pathway as well. As you recall, this is the intrinsic pathway and it requires a mitochondria, but extrinsic does not require mitochondria whatsoever. So it involves a TNF ligand on the plasma membrane. Upon binding of this TNF, which is a protein, antibody for example, it would commit a series of caspase reactions, as you can see, form as a dead domain. Upon formation of dead domain, etc., it would similar to this one, which would activate the caspase 9 from being inactivated. It would activate the caspase 8 from being inactivated, and caspase 8 would then eventually form as a caspase 3 from being inactivated, and hence giving us a rise to apoptosis. But just get the key here that this does not require mitochondria whatsoever, but this would require mitochondria. So let's now talk about apoptotic volume decrease. So if we, for example, induce a cell, like the lymphoblastic cell in this case, with a typical apoptotic inducer, it can be intrinsic or extrinsic. We classify two different stages. First stage is involved of potassium efflux. What it means that the potassium ions is going from inside the cell to outside of the cell. This is usually in the first 36 hours. The last 36 hours is a cellular fragmentation. So it means that the cellular is forming apoptotic bodies. It is dividing in the size. It's no longer the one whole cell. It's getting decreased in the size, and it's being formed a different part of it, right? It's being cleaved. But in this case, we're going to care about the first stage because that's where the apoptotic volume decrease is occurring. But in the first stage, we found it comprises two phases itself. So early phase, which is apoptotic volume decrease, that we're going to talk about, involves between 30 minutes to 2 hours. The first 30 minutes to 2 hours is being classified as apoptotic volume decrease. The last in the last phase is the late phase persistent shrinkage. So it's just losing a cell volume. We're not doing any cellular fragmentation, we're just decreasing the cell volume. So the early phase is apoptotic volume decrease phase. So let's see what does it mean. So apoptotic volume decrease is being classified as a flux of potassium and chloride ion from inside the cell to outside of the cell. Now imagine this is a human beta lymphoblastic cell, and we are involved with apoptotic inducer. In this case, it can be anti-fast antibody or extrinsic. So recall, we're talking about the TNF, right? TNF is a, you can say this is a anti-fast, right? It's a fast ligand, it's a fast receptor. And upon getting a fast receptor, I don't know why it says TNF, but it's meant to be fast receptor, right? I don't know what T and N stands for, but F stands for fast. So then we induce it with a specific antibody, right? We induce it with a specific anti-fast, and which would initiate us the apoptotic inducer. Now, upon doing so, what will we see in the first 30 minutes to 2 hours? We're observing a flux of potassium ions and chloride ions from inside the cell to outside of the cell. All right, so then this would, as you recall, activate apoptotic volume decrease. This is a major hall, if you wish. Like this is like a sole characterization of the apoptotic volume decrease, because we see these two events occur firstly. And recall, if you understand the regulatory volume decrease, this is one of the cases as well where the potassium and chloride channel would open and activate, and efflux of the potassium and chloride channel occur. Now, for us to be able to get a better understanding of this, what did we do is that we inhibited these two channels. Right? So if it's actually the apoptotic volume decrease, which is the first phase, it's actually been characterized by these two channels. If we inhibit these two, we should get no apoptotic volume decrease occur. Well, if we inhibited it with a specific blocker, and the VSOR channel, recall, is a volume sensitive outward rectification channel. If you block it with a specific blockers, we no longer reach the apoptotic volume decrease. So it means the cell didn't decrease in size, didn't increase in cell volume whatsoever. Okay, and this is of course being inhibiting of beta-human and beta lymphoblastic cells anti-fast extrinsic pathway. This extrinsic pathway involves that fast receptor activate the caspase 8. So it means if we don't do it and we don't activate AVD, we find something very, very interesting, because we no longer even activated the caspase 8 neither. Okay, so it means if we don't activate the AVD, we no longer activate the caspase 8 neither. So this means a very, very important thing. This means that the apoptotic volume decrease must depend solely on potassium chloride efflux, and the KCI efflux is a causative agent of AVD. We also know that the apoptotic volume decrease must be an upstream event in compared to caspase 8 or caspase 9 in the intrinsic pathway, but in this case it's an extrinsic pathway. So this means this is a major involvement in the growing of cell goodbye. If we inhibit this too, the cell would actually survive. Right? We can keep the cell immortal forever if you just don't let the AVD occur. Now, so we talk about extrinsic, right? Now we're going to talk about intrinsic. Whether would that have an effect on the intrinsic pathway too? It was a mitochondrial pathway, recall. Well, for that to happen, we induce it with STS. So STS stands for intrinsic inducer, similar to the FT-FAST, which is extrinsic inducer. Okay. So if we induce it with STS, it means we literally would activate the inducing pathway. We activate this process. We know the function of how STS would actually do it is not clear yet, but you just assume that it's going to activate this pathway. For example, release of the cytochrome C and etc. Okay. So we induce it with STS, we activated the AVD. Okay, we activated the AVD, apoptotic volume decrease, in this specific cell. So the experiments, we're gonna, for example, to minimize the effect of going through the extrinsic pathway. Because what I didn't show is that the intrinsic and extrinsic pathway are related to each other. So that is, for example, in not non-specific cell, if you induce it with intrinsic pathway, it can go to an extrinsic pathway as well. So we as a scientist have to pick a cell such as VHI, which is the mouse B cell lympho cell. It would only go through the intrinsic pathway and not in the extrinsic pathway. Similar to the SKW64, which is the lymphocyte cell, it only goes through the extrinsic and not intrinsic. Okay? So this is for clarification and accuracy of our readings and data. So in this cell, it goes through intrinsic pathway only. And apoptotic volume decrease occurred. Okay. Now, one thing very, very interesting, even in presence of BCL2. So let me show you BCL2. Where would that be? In this image, didn't show BCL2. So BCL2 involves here binding with BAX. So BCL2 is involved in the cytosol, or is embedded on the membrane of the mitochondria. It would bind with the BAX, preventing to form a pore inside the membrane of the mitochondria. So cytochrome C would not release, and hence cytochrome C would stay inside the mitochondria, and we would hence prevent the apoptotic from occurring, because there is no release of the cytochrome C to form apoptosis, right? So BCL2 is preventing a BAX to form a pore inside the mitochondria. So even in presence of BCL2, we still observe AVD occurring. So what does it mean? This means even if you inhibit the mitochondrial pathway, even if you inhibit the intrinsic pathway, apoptotic volume decrease is not yet being inhibited. So this means this AVD must be not dependent on mitochondria whatsoever. Okay? So just means that so far it's just dependent on the KCI. So we know that KCI is the only causative agent. We don't know what actually would cause KCI to give a rise to AVD. So there has been, for example, here we talk about if we now. So this was the case, right? So we didn't see. Now the case is just we're gonna identify the relationship between caspases 8 or 9. Recall the 8 was from the extrinsic, and 9 was from the intrinsic, right? From the mitochondria pathway. So we induced it again with the specific antibodies, and we found that they both take 1 to 2 hours respectively to form as AVD to give a rise to apoptotic volume decrease. But they both take 3 hours. They both take 3 hours, more than 3 hours, if you wish, to give a rise to caspase 8 or 9. Okay, so this means the AVD again must be preceding the initiator caspase because it is occurring at earlier stage than caspase 8 or 9, which are the product of the extrinsic and intrinsic pathway of apoptosis. So for us to get a better gain at understanding of this, so we have to inhibit these two caspases to better get a role at the apoptotic volume decrease. So if we inhibited these two, what would that have an impact, right? Would that have an impact on AVD? Is AVD inhibited? That's kind of related to caspase 8 or 9. So in this slide, we can show no. I mean, by the way, these are all from the experimental data I found from the internet, like from the journal articles. So this, in his report, what he did is that he found the STS and anti-fast antibody, which actually part to also to induce AVD. If we induce them with the pan-caspase inhibitor, so pan-caspase means everything. So it means non-discriminately, they would inhibit all caspases. So we will no longer form any caspase 3, not caspase 8, not caspase 9. So even in the presence of this, AVD was still occurring, but no longer caspase 9 and 8 was prevalent against caspase 3. So these two initiator caspases and effector caspases, which is caspase 3, did not give a rise, which is very interesting. It means AVD must not be dependent on this whatsoever, on the caspases neither. So AVD induction is not even dependent on the initiator caspases at all, okay? Which is very interesting phenomena to observe. And lastly, I'm going to quickly talk about what would actually give a rise to signals. What signals the AVD to occur? We know that KCI Efflux is a causative agent, but what is it that actually would give a rise to AVD? We don't know yet. So short answer is that we're not sure, we're not clear. But there is some here and there experiment done. For example, Shimizu, he found that the reactive oxygen species, which is means the radical oxygen anions from the mitochondria, right? Radical superoxide, if you wish, okay? That contains oxygen, which are very dangerous. They would give a rise to VSOR, volume sensitive alpha refined CO- channel. I recall VSOR is a channel that gives us AVD, right? So this means if this has been activated, and they found that AVD has been activated too. But the thing is, they only found that this is the true phenomenon in the intrinsic pathway while it was induced by STS in the HeLa cell. HeLa cells are a robust human cell line which is used for this kind of screening, and they didn't find this to be true in extrinsic pathway. But the thing is, there was another report done. What he found is that, he found that if in the mitochondria, if there's a serum deprivation, serum is a nutrition. It's nutrition for a cell to grow, translate, transcribe, have the essential nutrients, microelements to grow. This food, if we ever lack that serum, what would that happen is that it would activate the ROMA1. So ROMA1 is a novel protein. It modulates the production of reactive oxygen species. So this means if there is if it produces a reactive oxygen species, this reactive oxygen species must give rise to VSOR channel, and this VSOR channel must give rise to AVD. right? But he found that if you induce it with BCL-XL, which is in the mitochondria, it's again member of BCL2 family, this would solely inhibit the ROMO1 protein. And this means if we inhibit the ROMO1 protein, we no longer produce a reactive oxygen species, and we no longer should produce a VSOR channel. Okay? Hence, we should not be getting the cell decrease, right? Because if VSOR channel is not being produced, we should not get the AVD to occur. But so let's see here in again in other data. It's a bit hairy, but just get a vibe here is that. So if we induce them with the BSL2, which is a member of this, right? So if you induce it with BSL2, and if you don't induce it with BCL2, we call it, this is the STS, right? STS is the intrinsic pathway. So if you induce it with BCL2, presence of BCL2 or non-presence of BCL2, you will still get a similar decrease in cell volume. So this means even if you present the BCL-XL, even if it's here or not here, AVD is not yet being dependent. So if you inhibit the VSOR channel, or if you don't inhibit the VSOR channel, you would still observe a similar decrease in cell volume. So this means inhibition of reactive oxygen species by BCL2 would give you similar volume as a non-BSL2 cell. So this means the AVD must not be dependent on reactive oxygen species neither, because if you inhibit it, you still get a similar decrease in volume and you don't inhibit it. So it's very, very complex AVD. We just know that it has been dependent on the KCI Efflux. We don't show what is it being dependent on. So lastly, I'm going to conclude with this meme. I hope it finds you helpful. So you see, it is AVD. It is telling you that he doesn't care about initiator caspases or mitochondrial pathway whatsoever. Intrinsic, right? It doesn't really care about them because it's not being dependent on them, but it really cares about